All right, you guys, so April 29th, this is the second lesson for today, but I think you're going to find this one to be pretty straightforward. So I won't waste your time, we'll get right into it. Talked about arcs and how to find angle measures. And now we're going to find relationships between arcs and chords. A lot of the algebra here is going to be pretty straightforward, you guys. So the first theorem, and this is what you really got to have in your notes for this section, is these theorems. So in the same circle or in congruent circles, two minor arcs are congruent if and only if their chords are congruent. So if FG and JH are congruent, their chords, then their corresponding arcs are, vice versa. Here's an example of how to prove it. It's just done with congruent triangles, but I won't go through that. If you're interested in it, let me know. So a circular piece of jade is hung from a chain by two wires around the stone. JM and KL are congruent, so the chords are congruent. And the measure of arc KL is 90, so find the measure of arc JM. Well, the theorem we just looked at said if the chords are congruent, so are the arcs. So it's got to be 90 degrees. All right, so what do you think, guys? Chords are congruent, RS is 85, TV's got to be 85, okay? No big deal, you guys are not going to have too much trouble with this stuff. Okay, they give you the fact that the arcs are congruent, and so now I'm supposed to find WX, okay? Well, I know that these two chords have to be congruent then from that theorem, so I'm going to set those expressions equal to each other. I'm going to solve for x, and then I'm going to plug x back into the 7x minus 2 and see what I get, okay? So we'll set them equal to each other. The algebra here is pretty straightforward. Subtract 5x, add 2, divide by 2. Okay, so I know x equals 4, but I got to put it back into here. So 28 minus 2 is 26, and that's going to be the length of my chord. All right, so you guys give it a shot. Same scenario. Arcs are congruent, so the chords have to be congruent. So 3x minus 5 equals 2x plus 1. A little bit of algebra. Move the 2x over, move the 5 over. So I know x equals 6. I'm supposed to find LM, so I'm going to put that back into the 2x plus 1. 2 times 6 is 12, plus 1 is 13. Okay? I don't think you guys are going to have too much trouble with this. A couple more theorems. If a diameter is perpendicular to a chord, so AB is clearly a diameter, and we've made a right angle there, so we're perpendicular to the chord, then it bisects the chord and its arc. So XZ and ZY are congruent, XB and BY are congruent. And then kind of the converse, the perpendicular bisector of a chord must be a diameter. So the measure of arc DEF is 150, and we've got a diameter, at least portion of a diameter perpendicular to that chord, so it bisects the chord and the arc. So DE is just half of that 150 because it got bisected. Half of 150 is 75. Okay, so take a minute. Same thing, if this is 160, UX, half of it's got to be 80. Okay, this one's going to make us think a little bit more. Okay, so in the ceramic stepping stone below, diameter AB is 18 inches. So if the diameter is 18, then the radius is 9. Okay, so I'm going to draw that in there. That's got to be 9. Okay, and EF from here to here is 8. Well, the diameter bisects that, which makes this 4 units long. Now I've got a right triangle. They're asking me to find CD, which is the length of the one missing side on that right triangle. So I can say that x squared plus 4 squared equals 9 squared. But you have to think about it a little bit differently to do that. You have to consider that as a radius, which it is, and use that information that the diameter is 18 to get that. So that's precisely what they're going to do here. Okay? Here they're walking you through what I did in the picture, and now we're going to get to it. CD squared plus 4 squared equals 9 squared. The rest is some algebra. Subtract 16, take the square root, and so that's the length of CD. We can get an approximation if we need to, but the square root of 65 is good enough. Okay, so let's try one on our own here. Let's see what we get. So it says the diameter is 14, which makes this radius 7. It says that R to T is 10, which makes this 5. and it's asking me to find VU, which I'll just call that x for right now. So x squared plus 5 squared equals 7 squared. Okay, so (49 minus 25 is 24. And then I have to take the square root of both sides. So the square root of 24 is very close to 5 because the square root of 25 would be 5. You can use your calculator to find that, but that's how I would set that problem up. Probably the trickiest one you'll do in the homework today. In the same circle or incongruent circle, two chords are congruent if and only if they're equidistant from the center. Okay, and when I measure that distance, it's with a perpendicular, so be careful about that. These are definitely equidistant, okay? Well, actually, I take that back. It says EF and GH are both 24, so the chords are congruent, which means they are equidistant from the center. So if I want to find PQ, those two expressions there have to be equal, and then I can go ahead and put X back in for PQ. Okay, set them equal, do a little bit of algebra, put the 3 back in, and you get 9. Okay, so same thing here. It's telling us that the chords are congruent, so I know they have to be equidistant from the center. So I'm going to say that 3x minus 6 equals x plus 8. Got to do a little bit of algebra. Move the x over, that's a 2x. Move the 6 over, and I have 14. Divide by 2, I have x equals 7, but they wanted me to find RS. So I put the 7 back in. 7 plus 8 is 15. Okay? And there it is, you guys. That's all we have to do today. Your assignment 7 through 33 odds, skip 25. We're not going to do the proof. Everything else you should have no problem with. So good luck. Ask for help if you have questions. See you tomorrow.